Hi, in this video we're going to look at unpacking. So first I want to make a quick side note on tuples. So this is a tuple, right? We've seen those before. But what defines a tuple in Python is not the parentheses, it's the comma. So 1, 2, 3 without the parentheses is also a tuple. In fact, the parentheses are just used to make the tuple clearer. It's really more something to clarify, saying, hey, this is a tuple. But the parentheses don't create the tuple. The comma is what indicates that something is a tuple. Now, to create a tuple with a single element, you might think that if, with the parentheses, well, you would write parentheses 1. But of course, parentheses don't create a tuple. So what in fact happens is that this is not a tuple, and you actually just get an integer back. It's just like having, an expression 1 plus 0 inside parentheses. That's going to return a 1. That's not going to return a tuple, which is a good thing, right? Because you wouldn't be able to use your parentheses to do, to group either arithmetic expressions or to group Boolean expressions. So instead, we have to write 1 comma, and that will create a tuple. And if you want, you can keep the parentheses, but you still have to add the comma. That's what indicates the tuple. Now, the only exception is when you're trying to create an empty tuple. In that case, you can certainly use an empty set of parentheses. You wouldn't have something like that in an arithmetic expression or a Boolean expression, so that's okay. It's safe to use it that way, so Python will allow it and will recognize that this is an empty tuple. But if you prefer, you can also just use the tuple constructor instead. So up to you how you want to do it. All right, so packed values. First, let's take a look at, we talk about unpacking. So what do we mean by packed values? Well, packed values refers to values that are bundled together in some way, right? It's kind of a very vague definition. So tuples and lists are obvious. They've got a number of bundled values. This tuple has 3 values in it. This list has 3 values in it. Strings are considered packed values too, like this string here has individual characters, Python, so they're bundled together. Sets and dictionaries are obviously also packed values, like a set, which contains those 3 elements, or a dictionary that contains those 3 key value pairs. So in fact, any iterable is considered a packed value. So really, when we talk about packed values, we mean an iterable. And we talk about unpacking packed values, we really mean unpacking iterables. So how do we go about doing that, and what does it mean to unpack? Well, unpacking is the act of splitting packed values into individual variables contained in a list or tuple. So in other words, you create a tuple or a list that contains variable names, and then you take an iterable and you unpack the iterable into those variable names. So for example, if we have a, b, c equals this list 1, 2, 3. Now remember, this left-hand side is just a tuple with 3 values, and the right-hand side is a list with 3 values. So there's 3 elements in the list, so we need 3 variables to unpack, because we're going to then take this and put that into the first element of the tuple, right? So this is a tuple which has 3 variables, a, b, and c. So a will be 1, b will be 2, and c will be 3. In other words, the unpacking happens by taking the positions of each ones relatively on the left-hand side and the right-hand side. So the element at position 1 on the left will take on the value of the element at position 1 on the right, and so on. So it's a positional assignment. Does that remind you of how arguments were passed to functions and how they were assigned to parameters in the function? Yeah, right? That's exactly what's happening. We really are, when we're calling a function and we pass arguments to the function, it is then unpacking that tuple into the parameters that are defined for the function. That's exactly what's happening. All right, so how about unpacking other iterables? Well, we can unpack a tuple into another tuple. So we can unpack 1020 hello into a, b, and c. Remember that this is actually a tuple containing 3 values, and of course the left-hand side is also a tuple containing 3 values. And so we'll end up with a equals 10, b equals 20, and c equals hello. We can also unpack a string. A string is an iterable. So x, y, z, well, that's going to get unpacked, and A will be x, B will be y, and C will be z. So again, this relative positioning. Now, what this means, by the way, is that instead of writing A equals 10 and B equals 20 on 2 lines of code, you can, if you want, use unpacking and write it this way. A comma B equals 10 comma 20. That's a fairly actually common way in Python of giving initial values to your variables when you have multiple of them. Now, be careful with clarity of code. Something like this is easy to read and understand, but if it starts getting a little more complicated, yeah, you might be better off splitting it over multiple lines. But it certainly works. And in fact, unpacking works with any iterable type. And to understand the relative positioning, just think of the for loop. If you were to iterate, let's say, this tuple here, for e in 10, 20, hello, well, your loop is going to return 10, then 20, then hello at each iteration. Same thing, you can iterate strings. So if you say for e in x, y, z, well, your loop is going to return x in the first iteration, then y in the second iteration, and then z in the last iteration. So let's take a look at a simple application of unpacking. Swapping the values of 2 variables. So let's say we have 2 variables, a equals 10, b equals 20, and we want to swap them and essentially end up with b equals 20 and a equals 10. That's a fairly common task that's needed when we're programming. So the traditional approach might be something like this. In other languages, like Java, for example, this is how you would swap 2 values. So we start with a and b defined, right? A points to this 10, and b points to this object that is the integer 20. The first thing we do is we create a temporary variable that's going to point to the same object that a is pointing to. We need to keep track of that because the next thing we do is we change a. We make a equal to b. Now what does that mean? That means that we change the reference of a to point from where it used to point, 10, to now point to wherever b is pointing, which is 20. Now obviously we can't set b equal to a because we'd just be setting b to itself at this point. But that's why we remembered temp, right? That's why we had temp, which remembered what 10 was, or where 10 was in memory. So now we can just set b equal to temp, and that changes the reference of b to this original object that a was pointing to. And we're done. That's the swap, okay? But it did require the creation of a new variable. Now, if we use unpacking to swap the 2 variables, then we just do a comma b equals b comma a. And that's pretty cool, at least Bob thinks so. There's no temp variable involved, right? All we did was just unpacked b comma a into a comma b. Now, this works because in Python, the entire right-hand side is evaluated first and completely, and then the assignments are made to the left-hand side. In other words, what happens here is that Python evaluates this right-hand side. And so it actually creates a tuple. It creates a tuple in memory. The first element of that tuple is a memory address, which is where b was pointing to. And the second element is a, which is the memory address of where a is pointing to. And then it does the assignments. But at that point, we're no longer looking at the values of a and b when we're assigning to a and b. We're looking at copies of the memory addresses, because it's a tuple, right? That was created based on what we specified here. Anyways, that's kind of nitty-gritty details, but this is how we can use unpacking to swap 2 variables, for example. So that's pretty handy. Back to unpacking sets and dictionaries. So let's say we have a dictionary. It contains these 3 key value pairs. Now, if we loop in D, if we say for e in D, then what we'll actually be getting is our loop iterations are going to return the keys. So the first iteration will return key 1, second will return key 2, and the last will return key 3. So we're not looping through the key value pairs when we iterate a dictionary. It actually just iterates through the keys. So when we're unpacking D, we're actually unpacking the keys of D, not the key value pairs. We can, and we'll look at that later. So if we say a comma b comma c equals d, then what we actually end up with is a is key 1, b is key 2, and c is key 3. Or A is key 2, and B is key 1, and C is key 3, okay, or A equals key 3, B equals key 1, C equals key 2, etc. And now Bob's getting confused. What's going on? Why am I saying that it could be, either of those things? Well, you have to remember, dictionaries and sets are unordered types, unlike strings and lists and tuples that are ordered types, right? There is a concept of a first element and a second element and so on, right? You can slice those objects. You cannot do that with dictionaries and sets. They're an unordered type. You can iterate through them, but there's no guarantee of the order in which that iteration will return results. It might return the things, the keys in the order in which you added them in the literal, or that you appended to the dictionary as your code was, adding things to a dictionary. It might, but it probably won't. So you can't count on that. So the problem is that when you unpack this way, A is not the first element because there is no first element, because there is no ordering. So you have to be really careful with that. And because of that, it's rare that we would unpack in this manner a dictionary, because it's kind of a limited use here. There are uses for unpacking dictionaries that we'll get to in a subsequent video, but this is probably not the best approach here. All right, what about sets? Well, sets work the same way. Sets are also essentially like dictionaries, except they don't have values. They only have keys. You can think of a set as a dictionary that has keys only and no values. So the same thing happens, right? There is no concept of ordering in sets either. So even though I've created my set this way, if I was to loop through the set, it might print it out this way, right? There is no guarantee to the order in which those elements are going to come back when we iterate through the set. And so if we were to do this kind of assignment, A, B, C, D, E, F equals S, then we might end up with A equals P, B equals T, C equals H, basically the same thing that the iteration might be returning, and all the way up to F equals Y. So again, you cannot count on the order because there is no ordering. So something like that could be pretty limited if you're trying to say, hey, I want to get the first element. Well, there is no first element, so that's not going to, get the first element. Of course, there will be a first element because it's got to start somewhere, right? But who knows? It really depends on how the set or the dictionary is being stored in, in memory, and how the C code that's doing all this is actually working. But as a Python developer, we don't know how it's doing it. It's opaque, and so there's no guarantee on how it's going to come back. All right, so let's switch to some code and let's see all this in action. Thanks for watching, and I'll see you in a bit.